called means new Zenler. So means where you will get like means what's it? This recording session will be there forever, so you can watch it anytime.
That would be lovely. I can download it. No.
You can. I mean, what's it? It's like a web page. You can just watch it.
Okay.
So anytime you can watch it. That's it. So
That's
you
clear.
cannot download it. Yeah.
That's fine. I will now mute myself because my boy is roaming around here.
Yeah,
Nothing.
understood. And if you have any questions, like you just, I mean,
Yeah, I will definitely. I am an electrical engineer, and it's not very long. Like I done the degree, so I understand the thing. But since I do deal in a limited part, and the other stuff, these I deal in like very high level, So
yeah,
I understand the terms and everything, but it just I need a wee refresher.
yeah, done.
All right.
Huh?
Yes.
Good,
I'll
good,
mute
good to
then.
go. Okay. So today, like a short session, we have planned for 2 hours. Like already we have means 30 minutes on. So I mean, it's 90 minutes. We will try to cover the basics of power systems, basics of power system studies, and of course, power system simulation tools. And we will discuss more on steady state versus transient studies, and we will also deal with electromechanical transients with electromagnetic transients. So this is what I have planned, and this gives you an idea where you need to use ETAP, where you need to use Dixieland Power Factory, where you need to use pscad, what's the difference between pscad, or why people have to look at pscad, what studies people has to look at pscad. So all these things will be means what's addressed here. So let me very quickly give an introduction about power projects. So as of now, like I mean, so we have 25 power system engineers. We have completed about 120 projects in 19 countries, and we work across sector, like means industries, commercial buildings, auditoriums, theaters, shopping malls, sports stadiums, renewables. Like I mean, so to say, wind, solar, battery energy storage, microgrids exclusively work. I was there in ABB, and I have developed quite a lot of products for this battery energy storage systems. Along with the microgrid controllers, I mean, for about 4 to 5 years, and we brought that same thing to power projects also now. And this is conventional plants. Also, we work transmission and distribution, data centers, oil and gas. So these are all the sectors which we work. But I guess like this slide is says like what we do. So means what to say, we do all kind of power system studies. Like I guess I need not really go a bit more onto like one more slide to explain what is power system studies. Just give me a second. I'm getting another call. Venkat, can you just take it forward and introduce? I will come back.
Yes, sir.
Venkat.
Yes, sir. I will take. Hello. Can you hear me?
Yes, I can hear you. Go ahead.
Yes. Negi, this is Venkat. Myself and Gokul will be handling sessions regarding the pscad, and our head Selvakumar will be guiding us towards this course completely. Okay. And myself, I have experience. I have started my career as an what you say, that relay and control panel schematic designer, and after that I have started learning power system studies, and from there I have after learning power system studies basic, and I have reached the power projects, and after that I have been spending time with the power projects from there. And I basically worked in insulation coordination projects, and other studies also, and other power system studies like load flow studies, short circuit studies, and others one. And as well as we also do some battery energy storage and grid integration studies also. That's the overall background for me. And the studies oriented, I have did all my studies in India, especially particularly in Tamil Nadu. And after that, I have been searching for a job in 2015, where which year, on the same year I have completed my electrical and electronics engineering. And then from 2015, I have joined in an organization called as Change Content Analysis, and from there I have moved to power projects. That's the overall view about my career. Yes.
Right.
Yes. I have total experience of 5.5 years. You are basically from earthing studies background. Am I right, sir?
Yeah,
Am I
yeah,
right?
I am basically from earthing studies.
Okay.
Ah, you don't need to say me, sir. You can call me Himanshu. No, nobody says sir
Oh,
here. It's,
okay, okay, okay,
yeah,
okay, okay.
here, if you're talking to a colleague, they just say hi, mate, and if 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 you know you,
Yes, yes,
okay,
yes.
they can call
In
you by your
Canada,
name. Yeah,
yes, yes.
so you can say by name. It's fine. I don't feel very nice now if somebody says sir to me. So
Okay, okay, okay,
I'm not
okay,
used to.
fine.
In India, I work in that culture. Like people say sir, but nobody is sir.
Okay,
I can just say by
okay,
name.
okay. Yes, I will stick on to it. Okay, no, not an issue. Also.
Ah, it's fine.
Yes, yes, yes. Gokulji, Gokul,
Yeah, yes, yes. Yes, yes.
uh, if you just introduce yourself to me.
Hi, Himanshu. This is Gokul. So, basically, I'm with Power Project for the last 3 years. So, I've done 2016. I've completed my B, and after 2017, I joined Power Project. So, for the past 3 years, I'm with Power Projects. Basically, I've done my masters in power system also. So, in 2017, I joined in Anna University, so which is in Chennai itself. So basically, I have done projects on installation coordination in pscad, and I have done projects in ETAP as well. So basically, a load flow and short circuit and relay coordination projects in ETAP. So I've done some projects in installation coordination, basically in pscad as well. I'm expertised in pscad and ETAP. So that is very quick introduction about myself, Manchu.
That's good.
Yeah, yeah. Yes, Venkatji.
Yes, let us wait for some time. I hope Silva sir will come back. Silva will come back. Then
Yeah, yeah. Fine.
we will go through the slides. Is it okay for you, Mansu? Yes.
Yeah, it's good for me. Yeah, you can go ahead. Why not? Yeah.
Yes. Let him come back. I hope Silva is in some other call. When he comes back, we will go through the slides and we will discuss about it. Yes.
Yeah, perfect. Who is your client in India? Like who you deal with this insulation coordination? Like the electricity board or the private companies?
We usually did projects for Norway, basically where we have did specifically two clients called H&MB. For them, we have done some projects for Norway substation. Specifically, the substation name is Pagrabjel, and for that area, we have did some installation coordination for them. The substation is like 400 bar, 400 bar 300 bar 132 kV substation it is. And other than that, we have done installation coordination for the same client H&MV for some other wind farms also. And after that, we have done some projects for L&T. For that, we have done some installation coordination for 400 bar 220 kV substations, about 220 by 33 kV substations, where it is basically in Qatar, and we have done installation coordination projects for these countries.
All right. Good.
Mostly, I have mentioned some important projects on. Yes.
No, I was just asking like whether the people in India is also interested to do these kind of studies or just nobody cares.
Okay. Yes, we are doing. Myself and Gokul, and we have been doing this project for about for the past 2.5 years.
So where are you guys based in Chennai?
No, we are basically we work in power projects, which is our organization is actually located in Chennai. But due to this corona, this pandemic, we have been working from our hometown itself.
All right.
From
Right.
yes. Basically, we are all from Tamil Nadu.
All right. Good. I have some colleague from Chennai. They works
Oh,
in real sector here.
okay.
Is your colleague still busy?
Yes, I have missed out your introduction. You are basically now you are located in Canada.
No,
Or
no,
else-
no. I'm located in I'm located here in UK.
Okay, okay, in UK. Okay, fine, fine. Okay.
I am located in
I,
UK.
okay, yes, I think most of the companies are just moving towards what is it that zero carbon. That is what they mean aim by 2030, 2035. I have seen some
Yeah,
companies.
yeah, yeah,
Yes,
yeah,
yes.
yeah.
Mostly they
Everybody
have
is doing that.
yes, everybody is moving towards the solar, and mostly they have been concentrating in wind. I hope so. They have all of them have been concentrating on wind.
Yeah, there are a lot of renewable here.
Yes, yes. Because the
Wind energy.
system there are the system which operates there is much more different from our country.
Yeah.
Yes,
In our country, actually, there are like so many electricity board. Everybody have their own policies and own decisions and state government, and then here
yes,
here it's mostly like centralized.
centralized. Yes, yes.
Yeah.
Because some of my friends who work for some other country like US and all, they used to say like there are a lot of difference between our country and the work which we are doing from for their country. That is what I have understood. Yes. Yes.
Yeah, that's right. That's right. Do you work for any UK project? Like no.
I haven't done any. I haven't got opportunity to work for any UK, but I have, as I said, we have done some projects for Europe. We have done.
Europe you have done, right?
Europe, yes. For Ireland, Norway, and for Ireland and Norway, we have done some more projects. Yes,
All right.
yes.
So you not only give the training to the people, you also frequently do these projects.
Oh, yes. We used to give training to the training to our guys as well as the participants who are all from outside also.
Okay.
It is a part of our work too. Yes.
All right. Right.
Yeah, Venkat, sorry, actually, it
Ah,
was
yes.
another call. Like,
No problem.
anything you have started or?
No, sir. We haven't started. We just been introducing and we have been
All right.
just talking. Yes, yes.
Fine. So let me go on. So these are the like services what we do. It's a kind of pretty all power system studies, and I mean, so to say, this part which you are picking is like an insulation coordination, which includes like switching over voltage, lighting over voltage, very fast transient over voltage, transient recovery voltage, ferroresonance, transformer energization, etc. So that's one part which we do using pscad. We also do all kind of power system analysis using ETAP, Excel Power Factory, PSSE, and so forth. So we will probably means to discuss more on this. Means what say when we moving forward. In addition to that, like we do on this means what say battery energy storage systems, microgrids, so all those things. And of course, we do extensively grid connectivity studies, grid impact studies for renewable plants, and so forth. So that's quickly about the services what we do. So this is a power system consulting business what we do. In addition, like we do means training as another additional service, and probably we previously used to do only the classroom trainings, and because of this COVID-19, we have started online training as well. Now we are moving to learning management system where probably the recorded sessions will be available. The participants are able to refresh as and when they need. So that's the I mean what we have as on today, and this is about software expertise what we have. ETAP, Dixel, and PSSE. This is all for conventional power system studies, and we have like a pscad and DMTPRV. This is for an insulation coordination and probably means electromagnetic transients. And Dialex, that's for lighting. PVSYST, that's for solar plant design. So for microgrids, we are using Homer Pro or Homer Grid as well as React. So these are all what we are using. So that's also a specific reason why I have asked like how is the market in UK with respect to this microgrids, battery energy storage systems, and so forth, right? So moving forward, these are all our customers for our power system consulting services across the globe. And these are all few key projects what we have done. Like we have done 1500 megawatt solar projects in Kuwait. We have done wind turbine generator certification study for Senvion, and you may aware like this company is no longer available. So that we have done. And this is an airport in Saudi. We are currently doing another airport in Qatar. This is a Doha Mall in Qatar, and FIFA Football World Cup Stadium for Qatar, which we have done. And I mean, so say we have, I mean, also done quite a lot of food processing industry like Pepsi, Coca-Cola, etc. in the Middle East countries. And we are also done quite a lot of two-wheeler industries in India. And I mean, we have done the first fuel cell project in India. That's 2.5 megawatt Intel R&D campus in Bangalore. That's the first fuel cell project in India, which we have done the studies for that. We are doing quite a lot of projects for power evacuation in Malaysia. And I mean, to an extent, like we have done an insulation coordination project in Ireland. I guess like Venkat is the guy who has worked on that project. That's in Ireland, right, Venkat? This project file?
Yes, sir. Ireland and Norway, both countries we have.
Yeah. So that's the credentials what we have. There are some appreciations, and we won like Best Electrical Consultancy Services Award for 2020. This are all means what say quickly to say, and we are basically located in Chennai as well as in other southern part of Tamil Nadu near Coimbatore. And I mean, what say, let me move on to the topic what I thought of discussing. That is today. This is quick introduction about the organization. So let me go on to talk about the first about the power system studies, then power system simulation tools, then probably means we will come to that also. So let me quickly take means what say mind map. So let's talk about power system studies. What are the system studies which we have? Right. So I mean, so you can understand there are plenty of power system studies which we need to do. That majorly can be classified into steady state, and then probably means what say it can be classified into transients. This is the how this entire power system studies can be classified. And power system studies can be classified at the top level to steady state and transient. And in a transient, further it can be classified to electromechanical transients, and other one is electromagnetic transient. So means what say it can be classified to electromechanical as well as this electromagnetic. So means what is the then probably means what say we need to understand like what are the studies which comes under steady state. This could be many, right? So it's like load flow, right? Yeah, I'll just means what say use normal itself. Load flow. This probably you know like why we are performing load flow. I'll come to that and probably means discuss about all this. But let's just list out what are the steady state analysis which we have. So load flow, short circuit, harmonic analysis, relay coordination, arc flash. All the studies comes under steady state, right? So the tool used for this means what say you can use many power system simulation softwares. You can use it. Example is like ETAP, Dixilent, SKM, SIME. There are PSSC. There are plenty of simulation softwares, and approximately about 50 plus commercially available power system simulation softwares are there. And in India, we have like a software called MyPower, right? So this is about like I mean, what are the steady state analysis which we have, and probably means what's the software which we can use. So I mean, so the softwares what predominantly we can think of is ETAP. So that's popular in India and Middle East. Dixilent Power Factory, that's a software which is very famous in Australia and Europe. And PSSC, that's for the utility level projects. So this is the probably means what's the kind of means what to say the softwares and studies. And there are plenty of other simulation softwares. As I told, like you have SciMay, you have SKM, you have Aspen. There are plenty of softwares, and even if you Google it with a list of commercially available power system software, you will get means for say many power systems. So this all probably means what to say, like what you get. There could be, I mean, so say many simulation softwares. Here they're writing only few. Neplon, that's in ABB now, and SciMay, SKM, ERAX, yeah, and pscad and EMTP I will come a little later, right? So these are not the only softwares. There could be, I mean, so say list of 50, 100 plus simulation softwares are available. I guess, like I mean, so say some places they will list few. Means if you take US software, Aspen is so popular and so forth, right? There are many tools, free softwares as well, like mp4, pscad, right? Yeah. So PowerWorld simulator, that's quite popular in USA again, right? ETAP, Neplon, DSA tools, that's another famous software, and SciMay, SKM. So these are all kind of means what's a different power system simulation softwares which is available. But when it comes to the means market, means what's the ETAP has a predominant market in India, Middle East countries, including USA, right? But like Dixel and Power Factory now, I mean, sort of say with respect to this renewables, they are really playing I mean, sort of say an amazing work with respect to the renewables, including battery energy storage and microgrids. And PSSC is always for the whole country. So we can classify like this: if you have industrial distribution system, go for ETAP. If you're going for a large scale grid connected system for the whole country or a large state or whole Europe Union, go for PSSC. If you have a rich renewables, then if you want to perform the studies, then better go for an Excel and Power Factory. So this is the stuff which we can probably conclude from the power system studies perspective, right? And when it comes to this transient is further classified into electromechanical transients and electromagnetic transients. And this is where the two simulation softwares which comes into picture, like pscad and EMTPRV. EMTPRV may not be that much popular, but it's gaining a momentum. Both these softwares are coming from Canada. One is from Hydro-Quebec, right? So this is the two top tools which is used for electromagnetic. But probably means this is only tools, and probably means what I can in fact delete this, and like I can first put like, I mean, what are the studies which can come under electromagnetic. I'll also put up like what can come under electromechanical. When we say electromechanical, we can put like a temporary over voltage. We can put temporary over voltage. We can put means what to say SFO, that is slow front over voltage. Slow front over voltage. Slow front over voltage is a typical example which is coming from switching, right? And means what to say fast front over voltage. Fast front over voltage example is lightning. So this is I mean what to say lightning is another example. And probably means electromagnetic, there is another important aspect study which you need is like for a gas insulated substations, very fast front over voltage. This is applicable only for GAS stations. It's not really applicable for AAS stations. How you have like this CDGS is mandatory for gas insulated substations for earthing. Similarly, like when we go with the VFFO, means what say, means for a GAS, like VFO is mandatory, and you have to go with the pscad or EMTPRV. So in addition to that, we have like a transient recovery voltage, right? And that is TRV. So that's another aspect which we need to really look at, and probably means we need to check ferroresonance. Ferroresonance, and probably yep, we are almost done. And probably transformer energization can be brought out separately, or it can be clubbed with the switching itself. It can be, I mean, when we say SFO slow front over voltage, that's a switching over voltage. So transformer energization can be clubbed with that also. So this is the kind of means what say electromagnetic transients which we have. And for this, anyway, as I told, like you need to use a software, either pscad or means what to say, or EMTPRB. These are the only tools which is available, and what we are going to see is like a I mean what you say, a pscad. And electromechanical transients, you can further classify this into many electromechanical transients. One is like I mean what to say, angular stability or a transient stability, right? So then probably means what say, you can look at voltage stability. You can talk about like a motor starting, that could be an example, or motor acceleration study. That's another example of electromechanical. Yeah, everywhere T's in caps, that I can cut shorted. So if you probably means what say, go a bit more depth, like means what say, grid eye landing, load setting. So all those things probably means what say comes under this means what's electromechanical transit. So probably means if you look at this overall picture, when it starts from power system studies can be majorly classified into steady state and transients. And transients is further classified into electromechanical transients and electromagnetic transients. So means what say, for both electromechanical transients as well as a steady state, ETAP, Dixieland, PSSC, these are the tools which will be used. So I'll copy that here also. So you can use the same tools for here also, right? So electromechanical transients, you can use ETAP, Dixieland, and PSSC. So in a steady state analysis, you have means what say load flow analysis, short circuit, harmonics, relay coordination, and arc flash, right? So you have some fair idea of all the studies, right? Why do we need that at the high level?
Yeah.
Yeah. All right. So let's probably means also quickly conclude means like why do we need to find out the means why do we need to perform load flow? Like only questions why we will answer it. There could be many bullet points like this can be shared, so you can take it later for a reference also. Why do we need to perform load flow? Any quick answers?
Just to check the active and reactive power balances in the system.
Active power and reactive power?
Active power and reactive power flow in the system.
Yeah, yes, that's right. So power flow, that's right. Yeah. So that could be like P and Q, real power and reactive power. So this could be related to equipment loading. So means what say, this helps you to identify what's the percentage the equipment is loaded. Correct, no? So means if I have a transformer of 100 MVA and whether it is 80% loaded or 30% loaded, it can be identified only using load flow. Yes. Anything else?
No idea.
Okay, all right. It helps to find out what's the voltage at each and every buses. That's another important aspect. This helps you to find out what's the total losses in the system. This helps you to find out, I mean, what's the OLTC range which is needed, means or probably means whether on-load tap changer is needed for a transformer or not. If needed, like what's the range which is needed. This helps you to find out that, and it also helps you to put out like a reactive power compensation in HV, and probably means what say it's called a power factor correction in LV, whatever it is, it's both are the same. So means this helps like to identify the optimal reactors or optimal capacitor ratings which is needed. So that's another advantage of it. So equipment loading, voltage losses, OLTC range, reactive power compensation or power factor corrections. This also helps for steady state stability, whether the system is steady state stable or not. This helps for that, and it's also probably means what to say, talks about like means what's the generator terminal set point voltage which we need to give. These are the probably means different possible reasons why we need to go do the load flow analysis. So our probably means was this is all outcomes of the load flow. Why do we need to perform load flow? Load flow basically defines equipment loading, or then it probably defines like what's the continuous rating of the equipments. So It can find out, or it can help you to identify what's the continuous rating of the elements. And probably find out the voltage at all buses. It find out what's the total losses. It says like what's the OLTC range. It says like what's the reactive power compensation power factor correction which is needed. It helps you to say like whether the system is steady state stable or not. It helps like generator terminal voltage. What's the generator terminal voltage, right? So that's about load flow. Similarly, why do we need perform short circuit, or what's the objective of short circuit?
I think it's just to take the short circuit rating of the equipments and carry out the safety studies as well.
Yes. So it's for basically identifying a short time rating of the equipments. That's the one. Then probably it helps you to identify the finding out the braking, making, and DC braking capability of the interrupting equipments. It helps also to find out the over voltage during the short circuit. That might be surprising, but yes, like in a resonance that the systems are ungrounded systems, during single line to ground fault, the healthy phase voltage rises. So it helps to find out the over voltage, and it could be input for many other studies. Like I mean, for say, it's input for a relay coordination. It's the relay input for arc flash. It's input for motor starting. It's input for harmonic analysis, etc. So this is like I mean, what to say, quite a lot of other I mean, what to say, studies. It provides an input. So that's the purpose of load flow. And probably means what to say, if you compare this load flow with the short circuit, load flow is a steady state analysis, basically identifying the power flow in each branch. So it can decide the continuous rating of the equipments. It identifies the voltage, and if the voltage is not within the limit, it can means what say provide suitable recommendations, like provide going for an OLTC or going for a dynamic compensation, something like that. It helps to find out what's the total losses in the system. So probably means what say what's the optimal configuration which you can work out. It helps you to put up what's the total whether OLTC is needed for a transformer or not. This helps that way. And probably means what it also helps to means work out like what's the reactive power compensation which is needed, or power factor correction capacitor which is needed. It helps to find out whether the system is steady state stable or not. It also helps you to find out the generator terminal voltage. That's the purpose of load flow. But when it comes to the short circuit, it defines a short time rating. It given like for a breakers, making braking and DC braking capability over voltage. It's also an input for many other studies. Like, why do we need to perform harmonic analysis? To find out the total harmonic distortion at point of coupling. It helps you to identify, like, I mean, so say, do we need a filters to mitigate? Means it also probably helps you to identify is there any resonance in the system or not, right? And when it is needed, harmonics is mandatory. Like if you are going for any power electronic device which is present, like solar inverters or battery energy storage systems, UPS, arc furnace, any nonlinear loads you have, then probably means also you need to perform harmonic analysis. So what is the relay coordination? Relay coordination probably means what say can be classified to like low voltage, medium voltage, and probably means what say high voltage, or extra high voltage, ultra high voltage, etc. Low voltage means what say predominantly it is like a release, like you might be having MCB, MCCB, air circuit breakers, right? So these are the different equipments which you have, and predominantly you might be dealing with the releases there. Correct, no? MCB, MCCB, ACB, these are the elements, breakers which you have. So probably means here when we say it's an LV system, it's probably means what say most likely we will be having a release, it's not the relay. And medium voltage if you come, then it is like only overcurrent and earth fault protection, overcurrent and earth fault protection, nothing else. When it comes to the high voltage or extra high voltage, you have many things like differential, distance. If it is a transformer like restricted earth fault, so I mean what say excitation, under excitation, over excitation, overfluxing, right? So there could be I mean what say many other protections which is there. So then probably means what to say this also comes under a steady state. You need to give protection selection for the relays, so that helps you to means isolate the fault. So probably means what to say, 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 probably with the help of either releases in the low voltage systems or the release in the medium and extra high voltage systems, right? So low flow short circuit harmonics relay coordination, I guess that's pretty clear, like what we so far seen. R plus is helping you to find out what's the personal protective equipment which is needed, like how you are looking this earthing as a safety. This R plus is also a safety. If there is any R plus incident which happens within this within the switch gear, and probably means what's the impact, or probably means what's the damage which can happen to the human beings, those who are working in front of that, and probably means what should be the personal protective equipment the person has to wear so that he can be safeguarded. So it gives like incident energy, what's the incident energy of the system, and that is decided from the short circuit current and the relay operating time. So once you've done short circuit and relay coordination, you can go to R plus and you can find out means what's the personal protective equipment which is needed. So having said this, like you can also means what to say try something else as well. Means when I say like what is the different approaches, or probably what are the studies which is needed for a different perspective, that also we can which look at. So let's come for a little later. But I guess at least means what, see, when we talk about this power system studies, you have understood like a steady state. There are plenty of softwares are available, and what are the studies which is part of this, and probably means what, say each studies like why we are performing that means what, that might be clear for you. Any questions in this?
No, it's all right.
Yeah,
Brilliant.
it's straightforward. All right. Yeah. So I mean, what, see, then if we go to this electromechanical transients, we will be looking at the angular stability as a one important aspect that probably provides a critical clearing time. So this is again with an ETAP. So critical clearing time is a one step which we need to look at. Voltage stability probably means what, say we might be using a terminology called the voltage collapse proximity indicator to identify whether the system is voltage I mean it's very close to unstable voltage or not, that it helps. And probably means what, say we can go ahead with another motor starting in the transient, which is probably means what, say two different kinds. Dynamic motor starting study, where you model all this dynamic behavior of the motor, and to an extent like few people now doing a static motor starting study also, though it's a dynamic study. So what they assume is like they assume the motor is drawing a 6 times the current or 7.2 times the current, the continuous current with respect to this means what's it during till the starting of the motor. Grid islanding, load setting, this all comes under the electromechanical transients, which we are not really means what, say interested in, but at least means what, say this gives a broad spectrum like in a power system studies, where we are, or what's the study which we are focusing, where it comes from, right? As a part of this course, we are I mean what's the studying a small portion of power system studies, that is a transient. In that small transients, we are not really dealing with electromechanical transients, we are dealing with only the electromagnetic transients. To deal electromagnetic transients, only two different simulation softwares which is there across the globe. Unlike like means here there are plenty of softwares like 50 plus softwares, here it is only two softwares. One is pscad and other one is emtprv. Like other one which you have told atp, that's the tool which has been originally developed, and probably means what, say emtprv has just converted that tool into the graphical user interface. So means what, say commercially only these two tools are available, pscad and emtprv. Yeah. So when it comes to pscad or emtprv, you can identify like means what, say what are the studies which you can perform: temporary over voltage, slow front over voltage, fast front over voltage, very fast front over voltage, transient recovery voltage, ferro resonance, transformer energization. These are all the different kind of studies what we can perform using pscad. So means we will go probably means what, say depth on this means what, say individual studies one by one, probably like where do we need, what are the cases which we need to do, etc. But I mean what, say any approximate overview which you have with respect to this different studies, TOV, SFO?
Yeah, I went through the IEC 671 and I know pretty much everything other than ferroresonance.
Okay, that's then cool. Yeah, that's great. Okay. Okay, fine. So then probably means what say let's go to the studies means what say individual studies. Like today the plan is like means what say how do you want like means the session you want to means what say give some small assignments so that you can work on the next day and we will discuss more like that kind of parallel practice which you are looking for, or probably we finish the course then later you take means what say complete this working that how do you want this course to go?
I think if you do like the session wise and then you tell me to do the thing, that would be great. But unfortunately, I don't have the full license software, and I won't be able to model the like full extent. I think there's some limitation in trial version in the free license.
Yeah, yeah.
Yeah, then it would be
Yeah.
good. Like you finish, and then later on, I can take and I can maybe ask some questions and some answers.
Yeah, yeah. Actually, means what say we personally train this on most of the simulation softwares where we engage the participants with some small assignments on a daily basis.
Yeah,
Okay.
that would be good. Yeah, if they are allowed in free version in this, I would be able to do that easily,
Okay.
not a problem.
Okay. You have personal laptop, right?
No,
Or
I installed that. I installed this in my office laptop. It's not a problem. I can do those practices.
okay, okay, okay. Means what say what I'm trying to say. You might have some means what say non-licensed software also, which is available as a part of Google, which you can download, which has unlimited capabilities. That's what I just trying to say.
Which one? The pscad you mean?
Yeah. Yes.
You mean the cracks.
Yes. Yes. Yeah. That if it is
Right.
personal that works like means what's that means the only problem is like the student license, or if you some download some demo like that has a limited options like 14 nodes, you cannot go beyond
Yeah,
14
yeah,
nodes.
yeah. That's
But
what I
like
have.
yeah, but if you go with this SFO or FFO VFFO like means was that nodes will definitely not sufficient, then like you will be only a mere means what say just watching what we are doing, but
Yeah, yeah.
this is
I have my personal laptop. I can install something like that, and I can practice. Yes.
Yes, yes. So means what say we will probably means what say start with like means what say what are the studies the studies like how we can do, and probably means what are the things which we need to look at. Okay, for that like means what say I'll try to share some real time projects also like what we have done etc. But means ensure like that the informations are probably means what say strictly confidential because that we
Yeah,
have
yeah.
done.
You can twist the figures. It's fine.
Because like it means we always go with the fact that like our participants has to just not learn something on only the concepts or simulation software, but it has to be the implementable solution for the real time projects. Okay.
Yeah, yeah. I am doing this using my own money and own personal time to groom my career. So I want to take best of it. And if I get this thing done, like say in next couple of years, I will come back with another area and get some more from you guys, or
Yeah.
redirect more people towards you. So yeah. So
Yeah.
it will work that way.
Yes. So this is a one real-time projects which we are doing. Okay, that's going on. Like means what's it what we thought of like means we engage you means in a step by step of like what we have done the same way. Okay, we will give you all the inputs like along this you practice with us. That's how like what I have planned. Okay, but choice
Yeah.
is yours. Like if you have a time, means this helps you to take it to the next level, and that's the true benefit of this course. Otherwise, it's of not much any use. Yeah.
Yeah, yeah. We can definitely do that. Yeah.
Right. Okay. So let me probably means what to say. Just go and probably look at like what's the presentation which we have given after completion of this report. Okay. Still,
Yes.
this project is in conclusions. This one like means not final, but means what to say. We have done and we have submitted the report. It's waiting for the approvals. Okay. So
Yep.
this is like means 400 by 220 kV GAS gas insulated substation.
Yep.
Okay. The scope is pretty much everything. Like I mean, so to say, this covers TOV, SFO, FFO, but means was the presentation too. Like first report we have submitted and we have given this presentation, and we have
Yep.
done the second this one and we have presented the second report. So this is pretty much like what we have done for a pure consulting business. Okay, and probably means also you can practice it so that you can implement it in your real time projects.
Yeah, yeah. Of course. Yeah.
Yeah, so this is the probably means for say the single line diagram of the projects. I will try to share some documents, but only thing like you need to ensure like that is strictly confidential because means we have NDAs and other stuffs with an organization.
Definitely.
Yeah, so this is a 400 kV, and probably since you are already working in the means I think you might be aware like what is 1.5 breaker scheme. Needless to say, right? You know what is 1.5 breaker scheme, am I right?
Yeah.
Yeah. All right. So here you can see this is bus A of 400 kV. This is bus B. These are all two spare feeders. And here you can see there are three numbers of 500 MVA transformers that is stepping down from 400 kV to 220 kV. So this 400 as well as the 220 kV station is in our scope with all the scopes which is written. So three numbers of 500 MVA transformers, and it has like means what's the spare. Apart from that, if you look at this has three cables which is coming and two overhead lines which is coming. So means what say here you can see means what say REF super F3, REF super F2 and REF super F1. This are all probably the cables, and probably means what say this is Salia super that's an overhead line. So Salia super overhead line 1, overhead line 2. So here if you count 1, 2, 3, 4, 5. So means totally there are about I mean so say 5 outgoing feeders or incoming feeders, however you call, because 400 kV system is an interconnected system. So this has 3 cable feeders, 2 overhead line feeders, and 3 transformer feeders. And means what say this cable feeders has a shunt reactor because the cable injects a huge reactive power, and they have a shunt reactor to mitigate the reactive power injected by these cables. So that's how this overall system is connected. And then this is stepping down with three numbers of 500 MVA transformers to 220 kV, and 220 kV almost all are spare feeders except these three feeders, that's a cable outgoing feeders, right? So with the SLT is given, and probably means for say this this is a description like 400 kV has two numbers of overhead lines, three cables, 360 MVA shunt reactors, and three numbers of 500 MVA transformers. This is pretty much what we have seen here. Three cable feeders, two overhead lines, three transformers, three reactors, right? That's about like 400 kV network. 220 kV, like it's coming from three transformers, then three outgoing feeders, all remaining are spare feeders. So this is like the total structure of the systems. And I mean, so say we have done like all the studies, TOV, SFO, FFO, very fast transient, ferro resonance, transient recovery voltage, everything. And this is the means different voltage levels in this. And this presentation covers the first what is there in the black, and probably the what is in the red that's covered means for say as a part of separate slides, right? So this is what like I just want to means for say cover at that high level. I mean what say I will probably means what say go to this mind map as well. When we talk about TOV, temporary over voltage, means what is temporary over voltage? This could be I mean what say all of this four. Like it could be I mean what say coming from Ferranti effect. So when we say means what are the studies which we need to perform as a part of this temporary over voltage? The first and primemost is a Ferranti effect. Second one is a faults. When we say the fault, this fault could be LG fault, LL fault, LLG fault, three-phase fault. You can treat whatever the faults which you want. So I mean what say this are the faults which probably means what say you can look at that may create a temporary over voltage in the systems. Then probably means what say you can also look at from the temporary over voltage perspective, means what say the major culprit is like Ferranti effect, that's a steady state over voltage. Fault, that's a single line to ground fault in an ungrounded systems that results in a higher voltage in the other healthy phase. In addition to that, like you have an option like when there is a sudden load rejection or fault with the load rejection, right? When there is a sudden load rejection, that also results in the fault. Sorry, that also results in the over voltage. That's one thing which you need to look at in the temporary over voltage. And other one is load rejection or fault with the load rejection, right? There is a fault, and then probably means say the breaker is tripping so that their load is rejected. So these are all the cases which you need to look at. Basically, this temporary over voltage is used to identify the continuous maximum continuous voltage of this surge arrestor. So surge arrestor has multiple ratings. So this helps you to find out like a surge arrestor rated voltage, right? So means what say surge arrestor V, which I put. So it helps you to find out the surge arrestor basic voltage, right? So the four different cases which we have looked at. Look at this. This could be like a Ferranti effect. Means one thing, because of the shunt capacitance of a long transmission line, which means which increases the voltage at the receiving end. Faults, load rejection, fault with the load rejections. Yeah. So here, like what is we have done with respect to that projects, and what is the measured voltage in peak? What's the measured voltage in RMS? Everywhere what's the we are giving, and you can look at like what's say how many cases we have performed the study, how many cases which we have performed the study, right? That's around what's say there are 25, right? I guess like for whatever maybe the reason the bottom is not appearing, but there are 25 different cases which we have done. So the first and foremost, like what's say when you talk about this temporary over voltage, the task is like how to identify the cases or how to define these are all the cases which we need to run, right? So we have just listed blindly like 25 cases, but what's say Ferranti effect, why only these two cases? Load rejection, why only this case? Like LG fault, LLG fault, LG fault, LLG fault. So fault with load rejection. So what's say 220 kV, 400 kV. So how we have arrived this? So that's one story which when you go to the simulation software, what's say you how to model these elements that you will see. So we adopt a procedure, a step-by-step procedure to tell you like what's say how this single line diagram has to be modeled. That means like how this cable has to be modeled, how this overhead line has to be modeled, how the CT has to be modeled, how the VT has to be modeled, surge arrestor has to be modeled, transformer has to be modeled, reactor has to be modeled, right? Circuit breaker has to be modeled in closed position, open position. For temporary over voltage, how it has to be modeled, how it has to be modeled for switching studies, how it has to be modeled for lightning studies, and how it has to be modeled for TRV studies. So we see all in a combination for different different studies and different elements for a different scope. We will go one by one. That's where like we take this approach, finish all the elements for this, perform all these cases, and along this go like you also take some time, and probably at the beginning it looks like it's a bit difficult, but over the period, like once you come up with some practice, you will be able to achieve the same results like what we are getting. So it's all more kind of a practice. First project, a second project, or a third project, people may struggle, but probably once you complete 2 or 3 projects, then you will be able to identify everything. So today, like I'm trying to give like what we see as a overall and how this course progress. And if you feel something to be changed or modified, you can feel free. Like our guys will be able to adjust the the way they present, or probably they may adapt to what's the need of you, right? Right. So these are all the different cases up to all the 25 cases. What is the peak voltage and what's the RMS value, which they have listed out. And after that, the conclusion has been made. The continuous over voltage of a surge arrestor class 4, surge arrestor class 5. There are two different surge arrestors which has been taken. So continuous over voltage is 264 and 269 here. But here, the maximum voltage what we are getting is only the 238 kV that happens with the Ferranti effect, right? So this is an RMS value and this is a per phase value, like 400 kV system, 400 by root 3 is 230 kV. But because of Ferranti effect, it is not at 230 kV, it is slightly higher than 238, it is higher than 230. But surge arrestor has a continuous over voltage capability of 264 or 269, so this is not a problem at all. Then we look at 1 second and 10 second rating. So typically 1 second and 10 second rating has to be compared with the faults, right? When there is a fault, the fault will be isolated well within 1 second. So during a fault, like what's the rise in voltage? The maximum voltage is 304.57 for 1 second as well as 10 seconds. And probably the surge arrestor class 4 or a class 5, whatever you select, the voltage is like 386, 380 and 358, 356. So this is higher than this. So temporary over voltage, your surge arrestor should not means what say respond to that, or your surge arrestor should not means what say allow the means what say this temporary over voltage currents to flow through the surge arrestor. So surge arrestor should not allow this current during the continuous over voltage, which happens because of Ferranti effect, or happens because of line to ground fault or line to ground fault, etc. When there is a situation like this, and if there is a rise in voltage, that should not result in the current flowing through the surge arrestor. So surge arrestor should means what say act as an arrestor, or probably it has to act as a means what say low impedance path only for the lighting over voltage or a switching over voltage or something like that, right? So for this normal events like continuous over voltage, this should not allow any current. This has to act as a means what's a high resistive element. And even when there is a single line to ground fault, where there is a rise in voltage, for that also the surge arrestor should allow means what's should not allow the current. That means it has to behave with the infinite impedance, or theoretically the maximum possible impedance. So the same thing study has been repeated for 400 kV and 220 kV, and the results are presented. And this is the surge arrestor characteristics, right? So means what say this surge arrestor characteristics, if you look at, this is a continuous operating voltage, right? This is the continuous operating voltage which you have here, right? So this is U by UR, right? So means what say here, like means what say without pre-stress, it can probably means what say withstand up to this, and with the pre-stress already means what say if there is any means what say additional previously the rise in voltage or something, then this will be something like this. So this gives like means what say what's the power frequency voltage versus time characteristics. So whenever there is a rise in voltage, how means the surge arrestor behaves. So if the voltage is like 1 per unit, if the voltage is 1 per unit, means what say this surge arrestor without pre-stress will withstand means what say 1000 seconds without any problem. And one make a note like means what say you need to understand, one is RMS, other one is peak. Like means what say UR is like what's the value which we are entering is the peak value, but the actual value what we are talking is like the rise in voltage. So means even if you means what say your RMS value that which is increasing to peak value, that will not have any problems. So to try to give a conclusion for this case of this single line diagram. So this single line diagram we have means trying to install the surge arrestor for lines, transmission lines. That surge arrestor, what should be the class which has to select, class 4 or class 5. So means in Ferranti effect case, or in temporary over voltage case, or in probably means what say load throw off or a fault with the load throw off, all these cases the rise in voltage is well within class 4 and class 5 rating of surge arrestors. So we can choose either class 4 surge arrestors or class 5 surge arrestors. Yeah, any questions?
Oh, no question.
Yeah, all right. So then what I do, let me stop this. So probably means what say this looks theory, it's fine. But let me ask Venkat or Gokul to share their screen, and probably means what say take you through like means what say how to model maybe 1 or 2 elements for this temporary over voltage studies, and probably give a small assignment, so that like next day tomorrow when you come, like you can work something and you can come, so that like we can review like what you have done, and we can correct what's the mistakes you have done, or probably means what say that we will guide you like how that has to be done in a right way. Then probably means what say along the course you will not feel that that's a theory session, but it is like a I means what say parallel working session. I guess that's fine for you, right?
Yeah. Brilliant.
Yes. Venkat, can you take through the simulation software? Like.
Yes, sir. Yes, sir. I will take.
Yeah.
Just a minute.
I guess like Himanshu will be available for next 30 minutes. Today is a working day for him, so you can quickly take through the software and probably means what say.
I can do extra half an hour if if you are
Oh,
available, it's fine. You know, I
all
can go half 8 here, so I can go until half 9 or something. It's not a
all
problem.
right.
Yeah.
Okay, fine. Yes, Venkat. So please go ahead and probably give some small assignment as well.
Okay, sir. Okay.
Yeah. Okay.
Just wait a minute. I will share my screen. Yes.
Problem, take your time.
I hope my screen is visible to you. Yes.
Yes, I can see it.
Yes. Yes. Thank you. Yes, I will start. I will start with some basic introduction about where you can see the components and all. Like that, I will start. Uh, in pscad, you can see that there is something called as master. Yes, this is the introduction page which will open for you whenever you first open a pscad file. Okay, here you can see that there is a lot more information about what are all the inbuilt library equipments which are all inside the pscad. These are all the inbuilt files which are all inside. Okay, here you can see that there is something called as passive element. When we go inside this, here you can see all those data like passive elements means just like resistor, capacitor and inductor components. Like that, here you can see that there is something they have developed their library and they have kept inside. If you want to keep some load, here you can see there is something called as fixed load. This you can take it from the library. Like that, you can see lot of passive elements will be there here, like transposing of wires. When we are going to transpose some wires, here you can, from this area we can take it. Like that, here you can see lot of informations like sources and breakers, HVDC equipments, tracks, cables, and like this there are a lot of equipments in the inbuilt library of pscad. Okay, other than that, if you want to develop your own component with using this active and passive elements, you can find you can do that. Okay, that part we will see in the upcoming sessions. Okay, now I will take you to how to open a new file and what are all the informations which will be available in the menu bar. Like that, I will take you through. Here you can see that there is something in the left side corner. I hope you can see that it appears like pscad button. When you just go and wait your mouse here, you can see that pscad button will appear. If you click there, here you can see that how to create a new file or new project or new workspace. It is all different. When you create a new library, it is like adding your new library. Like as I said, this is one library. This is one library. If you are doing some if you want to if you are doing some project, if you are doing some project, if you want to create to your own library, then you can choose this option, new library, and you can create your library. This part also we will come later. Okay, we will now start with new workspace or new project. Okay, now I am clicking like new workspace. What does it new workspace means? Just I'm just clicking. Now I have opened a just wait. Yes. I have now opened a new workspace. This is a new workspace for you. If you want to save the new workspace, what you can do is like here you can see that. Just wait for me. I will open a new file also. Then only you can clearly uh, know what is this new workspace. Just to give a name, for example, I am just giving a simple example. Just I am giving my name as Venkat. Okay. And first of all, you have to choose your destination path where you are particularly saving. Here, generally, it takes the document path. If you want to, give a different location, just click this option, and here you can see that a lot of options will be available. And then in that location, in this available options, you can select a make new folder, and then you can put all your files in that. My recommendation would be don't go for the documents file. Create a separate path for your file, and in that location keep that keep all the files which you will be working on. Okay. In this, for example, I will go into this all sources file, and I will just click OK. Here you can now you can see that all sources path has been appeared. In this, I am just clicking, putting my just a name as Venkat, and I am just clicking OK. Here you can see that now my new file has arrived. Right here you can see that there is something called as this workspace. This is called workspace. My workspace is named as untitled, right? What is the difference between workspace and normal file is like, just I will show you. I'm just creating another name. Okay, I'm just giving it as a name, and I'm just clicking OK. Okay, in this particular workspace I have two files, right? In this particular workspace I have two files. If I am just clicking save, and I'm just closing this file, means it will ask like, do you want to save this workspace or not? And if I just click yes, what happens is like it then asks for a new location where I have to save this particular file. I'm just going to the same location where I have I'm just saving it in my let us say in my documents. Okay, in my documents I'm just going to save. I'm just giving to save it as let's say just click OK. I have just closed. My file has just closed. Just wait for a minute. I will open again.
Sorry, you close your screen as well.
Yes, I have closed. As I said, no, it has asked for whether you want to save the file or not. Like that, it has asked. Like,
no, but you are
right?
not sharing your screen. That's what I mean.
Venkat, your Microsoft Teams is closed. You are not shared your screen.
Yes.
Yeah, you accidentally stopped your screen as well. That's what I'm saying.
Yes.
It's okay now.
Yes.
Yeah, it's good now.
Now, if we click this pair option, what it will do is like, can you see this? The project files I have worked also came together with this. This is the difference between a particular workspace and the particular project. Okay, if you just click this save button, the particular project only will be saved. If you want to save the workspace, then when you go for this closing option, completely when you are closing, just click yes, and then it will close. And what are all the work which you have done within the particular workspace, it will all be saved in the particular workspace. If you just click that particular workspace, all the files which are included in that workspace will be displayed in the particular page. I hope this is clear for you.
Yeah, very much clear. Yes.
Yes, thank you. And then the other options which I want to tell you is like this menu bar. What this menu bar contains is like just the editing options, like copy paste options will be there, and the build to modify this and all the algorithms which will run background when we use this options, like when you want to run the particular project, you can use this. Okay, like this here you can see this run button. These are all the options which are available to run a particular project, which are all available. And the stop button is like when you are running, if you have found that I haven't modified the data which I want, then you can stop the simulation and then rerun the simulation using this stop and run button. Like that they have given the pause button and like that options and all. These are all these are all the data which are all available in the menu bar. Like then the other option which we generally use is like this wire option. This wire option, why we use is like it is generally used to join some two components. For example, if I am taking if I am taking a resistor, if I am taking a resistor, or else from the components page itself we can take. I'm just taking an inductor and I'm just taking an resistor. If you want to join these two components, you can use this wire and join this. Okay, this is the main use of this wire mode. Whenever you are creating your own module or something, we can use this wire to join particular equipments, resistor and inductor, like that components. Okay, and then the next one is like project. And then this project settings and all, mostly what we will do is like here there is an option called as workspace, right? Whenever I go this side, the workspace will pop up, and in that itself we can do all this, like the options which is appearing on the menu bar. That options we can work it out here itself, like what is the duration of run and duration of time step and clock step options, which we will see all those options what it does with the particular example. Okay, these are all the important things which are all required for you when you perform a particular simulation. And that also depends on the type of application for which you are performing the simulation. Okay, that part we will come to this. Okay, in the later off we will come to this. Okay, and then the next one is like viewing options. I hope this also we will come option by option. Okay, then the components. These are all the basic components which are all available in pscad. Like as I said, in master library some components are there. It is nothing but the inbuilt library. Like that also we can choose some components uh, from this page itself. Not going into the library, we can get the options which are all available here. Okay, and then the models is like when you go into the model, here you can see that, for example, if you want to put a coaxial cable, then you can click this cable option and you can just click here. Then the particular cable model or the data which you want can be using this models type. These are all about the menu bar options which are all available in pscad. Okay, and go through a simulation. Okay, now I will explain what is this project settings, this duration of run and solution time step and plot step time step. What it does is like that I will explain now. Okay, now for example, I'm just clicking. I have created a source. Okay, I have created a source. Okay, and I have kept a multimeter, which is this multimeter. And this multimeter where I have taken is from this area I have taken the multimeter. Here, can you see this? This is multimeter. Okay, this multimeter I have taken and I have kept it here. Okay, and I have created a fault in my bus. This is bus. Okay, I have created a source and I have connected my source to the bus, and I have created a fault at the particular bus. this is for when you go inside the fault, where I have took this fault means from the master library I have took the fault. Here you can see this, there is something called as fault that I have took from the library and I have pasted here, and I am using this for my simulation purpose. Okay, when we go inside this fault, here you can see this, what is the type of control which you are giving to this particular fault type. This part we will come now. We have two controls here. One is like internal control and another one is like external control. When we give internal control, all the type of options which we are going to give for this particular fault will be coming from inside this tab. What happens when we click external is like whether when we have some external input for this particular fault, that we can give it from the external fault. That part we will come later. Now we will see only the internal fault. Okay, what it does is like first we will click on the fault type control, which is nothing but internal, and then I will choose like what is the what is the clear possible at any current. It is like whether it, 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 it is mostly suited for the breaker type of equipment. That part we will come later. Now we will see the basic part. The options which we have to use is like internal, keep it as internal, and then choose the type of fault, whether your fault is grounded or not. That option you can click from here, like yes or no. If you want the neutral to be grounded, then you can click yes, or else you can click no. Now I'm just clicking yes, and then the other option which we want to know is like the fault type which we are going to keep here. Now I'm just going to keep like single line to ground fault. So I have kept my A phase like yes, and then the neutral to ground, because I'm just creating single line to ground fault, so I have kept it as yes. Okay, when you are performing three phase to ground fault, all the options will be kept yes, and if you are going to perform only double line fault, then you have to take out this fault to neutral, and the other option which is available in the before page also, you have to keep it as neutral, and then you have to run the simulation. In our case, we are going to run single line to ground fault, and I have kept it okay. Now we are going to perform the simulation, but before that what we have to do is like we have to give a command like at what time your fault is going to happen in the system. Okay, like that what I am doing is like I'm just applying the fault at 0 point, let us say I'm just applying the fault at 0.5 seconds. Okay, and my duration of fault is like you can, if you want to clear the fault within 100 milliseconds, then you can give it as my duration of fault as 0.1. Then after 100 milliseconds, like after 0.6 seconds, my fault will be taken. But here what we generally use is like here we can keep it as 1 second. Let us see what happens. And I have kept my project setting as 0.5 and solution time step as 50 and channel plot step as 250. Okay, now let us see. Now I am just going to run this simulation, and before that what we have to do is like we have to take that output from the particular file. That is what I have done here. This part we will come a little bit later. Now we are going to we are just trying to find what this option does, what this solution time step, channel plot step, and what it does is like. That is what we are going to see now. I'm just going to run the simulation. Here can you see this, there is something called as run button that I am just clicking. what was the thing I have done wrongly is that I have run the simulation for 0.5 seconds and I have kept the fault at 0.5 seconds so that the system has not given any fault currents. Now I will keep it as 0.3 and I will rerun the simulation. Can you see this?
Yes, I can see that.
This peak current. Yes, here you can see the plot which is happening. What I have did is like I have created a single line to ground fault and I have created a source, and what is the fault current is that what my graph is showing here. Okay, now what we have done is like here you can see this. Here the duration of run which I have kept is like 0.5 seconds, that we can see here, right? From the project setting, in the duration of run you can see that there is about 0.5 seconds, so that the simulation has run for 0.5 seconds. The next one, which is called 50 microseconds, the solution time step. The solution time step is nothing but what it does is like it takes solutions. Whenever we run the simulation, what it does is like the algorithm will be running in background. What it does is like it will take solution for each 50 microseconds. Okay, for each 50 microseconds, this particular software will take output. Okay, for 50 microseconds, for each 50 microsecond it will take the information. Okay, but it has recorded for each 50 microseconds. But what we have done is like we have shown like 250 microseconds in channel plot step. What it does is like it will plot only the data which are all available in 250th microsecond. Okay, that are all the data which will be plotted in the particular this area. Okay, this area what it does is like it will plot the information which is available on the 250th microsecond only, it will plot here. But if we keep it as 50 and 50 microsecond, if we keep it as 50 and 50 microsecond, what it does is like it will take information for each 50 microsecond and it will plot the information for the 50 microseconds itself. Can you understand this point?
Yeah, I understand that, but what I'm asking on this is, see, if you put that 50 and another 50, is that affect like a result accuracy, or it doesn't matter?
Yes, it is the matter of accuracy. Yes, you are correct. It is the matter of accuracy. Hello.
Yes, I can hear you.
Yes, it is the matter of accuracy. You are absolutely correct. It is the matter of accuracy. If you want to perform the simulation fastly, what we it all depends on the application for which we are performing the simulation. For this
Right.
application, if we don't need that much information, we just need some values, some particular values, then we can keep it as somewhat higher values. Okay, then if we want somewhat accuracy, then we can keep it as 50-50. Below that we cannot go. What is the channel time solution time step which we have kept, that is what the minimum value which we can keep it in channel plot step. If we keep it as 25, what it does shows is like if we click OK, if we go again inside, it will keep it as 50 because that is the minimum value it has recorded, and that is the minimum value the data from where I can plot in the particular graph. I hope it is clear for you.
Right, I get it. Yes.
Yes. Thank you. And then this is about the project settings. This is about the project settings. Okay, and then we will go for. Then we will go for. Then we will go for how to model a source. Okay, there are different types of sources available. Different types of sources available. I hope you can see my screen. These are all the types of sources which are all available in pscad. Okay, This particular is used for the solar MPPT controller, like that is what here. And for harmonic injection, if you want to inject harmonic injection, then you can use this particular harmonic injection source. And then if you want to inject a current, then you can use these three types. And if you want to use some sources with like RRL, with sources may come with some resistance, some inductance, like that, then you can use these options, like there are available options which are all available here. Okay, now I will the options which we generally use is like we will use this ideal source. We will use this ideal source. We will use ideal source. And the other option which we will use is like this one. Okay. But whatever you see in library, just copy it and use it in your particular project file. Don't ever change something in the library file. Okay, if you change something in library file, and if you have forgottenly chose save, then all this data in the library will be kept as you have done in the particular time. Okay, so don't change anything within the library file. Just copy whatever the equipment you want from the particular file, and just paste it in your project location, and you can perform the simulation with that. Okay, in this source here you can see this is an three phase source. Okay, this is an three phase source, but I have shown it as a single phase. How we can do is like just double click on this. Here can you see this option like graphics display, right? In this graphics display you can choose single line view, then click OK. Here you can see that this has become a single line view type of source. Okay, just double click it, and we will see. Okay, here can you see this is the name of the source. Whatever the name you want, you can give for the particular source. Okay, and this is like the base MVA which you are going to give for the particular system. Okay, this base MVA, how we have this all depends on the base MVA which you are going to choose for the particular network. Okay, and the base voltage is like what is the voltage of the particular source. For example, here I'm just using like 400 kV, means I have to click my basic voltage as 400 kV, and the base frequency which we are going to keep for the particular network. Okay, I'm here choosing 50 hertz system. Okay, and what this voltage input time constant does is like I will explain this with the graph. Okay, and if you are choosing this as an infinite bus or not, I'm just choosing this is not an infinite bus. Okay, I'm just clicking as no. Okay, and then other option is like whether your zero sequence and positive sequence differs. There is something called as positive, negative, and zero sequence. I hope you know about the zero sequence, positive sequence, and negative sequence.
I know it. Yes.
Yes, thank you. And then there is something this option which is used for used to give whether your positive and zero sequence differs or not. There is an option in pscad to give this. Here I have chose yes, means here you can see this zero sequence as enabled, right? If I choose no here, now here you can see this zero sequence as disabled. Here you cannot type anything. Just the arrow mark will appear, but you cannot type anything or erase anything. If you want to do something in this particular tab, here you have to choose yes. Then you can see these two options have been enabled. This how it enabled is like the data which we have impedance for data format we have chosen. Here we have chosen as R plus JX, like resistance and reactance we have chosen. If you are going to give impedance and theta values, then you can give z and theta. Then if you go inside this zero sequence, here you can find the impedance and phase angle. Okay, and if you are going to give the resistance, as I said, it depends on the information how you are going to provide this for this particular source. Okay, and display, what it does is like whether you want to display the information which you have given inside this particular tab, then you have to click yes, and if you click OK, then here you can see this, the information has appeared here, right? I hope up to this point you are it is clear for you.
Yes.
Yes, thank you. And other than that, here you can give the value for particular positive and zero sequence impedance, and the internal output. What it does, this output, this tab will be available in each and every equipment which you choose in pscad. What it does is like it helps you to plot the values of the particular current or power or voltage, whatever the equipment does provides, that you can plot outside. Okay, in this if you want to plot the current, then you have to give the data for this particular phase current, like IA or IB or IC, whatever the name you want, you have to give here, and then use this name to create the output. Like, can you see this? There is something called as data label, right? Hello.
Yes,
Hello.
I can see it. Yes.
Yes. Here you can see we have given we are going to take output from this particular internal from this particular source. So what I have to do is like I have to mention the name for the particular name for the particular data which I am going to take out from this particular source. Okay, here I have taken the name as IA. Then what I am going to do is like I will just click OK, and I will use this data signal, and I will just paste here and give the same name as it is, as you have given in the particular source. Just copy it and just paste here, and click OK. And then the other option which pscad provides is like if whether you want to see the output in graph format. For graph format you can use this. Can you see this? There is something called as output channel, right?
Yes, I have used it. Yeah.
Yes, there is something called as output channel. With this, you can plot the information which is getting from this current in the graph format. Other options which are available is like there is something called as just wait for a minute. There is something called as control panel. Yes, there is something called as control panel. From this area, I have taken this. There is something called as control panel. What I have to do is like I will click this graph button. And I will right click this. And here you can see this graphs, meters, and controls are there. Right here now I am going to add this data as a control. Okay, then what I will do is like I will just copy add as control, and I will just choose this option as add as control, and I will just paste here. Sorry. Now what I have to do is like I have to choose as a add as meter. Okay, now when I click this add as meter, what it does is like this information which will be shown in a graph format will also be shown in the meter format also. Okay, like this you have other options, like when you we will see all those options in the upcoming sessions. Okay, now I have shown like two options, like how to take a graph, and how to plot using the in a meter format. If you want to see in a plot graph format, what we have to do is like just click this graph like pan and just right click on this, go to graphs, betas bar controls, and just can you see this, there is something option called as add overlay graph with signal, right?
Yes.
Just click this option, and here you can see this, the particular tab will appear and your results will be plotted in this particular graph when you run the simulation. Okay, when you run the simulation like this only, I have done for this particular source. This is the source which we have modeled for this particular project. Here I have given the name for the source, and I have chosen the base MVA, and I have given the voltage, and I have chosen the 50 Hertz. This part I will explain with this graph. Okay, and I have chosen infinite bus as no, and I have chosen zero sequence and positive sequence are different, and I have given the data in the name of R plus JH format, and I have given the view as single line view, and the data which the display I have given yes to display the data to see from outside itself. Okay, the positive sequence data I have entered in ohms, and for zero sequence also I have entered in ohms. Here I have not taken the output from the internal. Other than that, what I have did is like I have put an multimeter in this location, and I have taken the output from this particular multimeter. If you want to choose, if you want to see the current, then you have to keep yes. Okay, and then if you want to see the voltage, if you want to see the voltage, keep yes here. And then when you go to the next option, signal names, here you can see this this option has enabled now instantaneous voltage. Whatever the option you will be enabling in configuration, that will be the only options which will be available for editing on the next tab to come. Okay, here I have chosen voltage as yes, so I have been given the permission to give a name for this particular voltage, right? Now I am going to see this is and see this out this voltage. What I will give is like just give as voltage. Okay, just I have kept it as voltage, and I will just click OK. And now I'm going to see the voltage and current, right? For current I have already taken the input, right? For current I have already taken the input. Like this, what I want to see is like I want to see the voltage also. Like I will choose this, and I will copy this. You can use Control C for copying, and I will paste here and paste here. Just what I want to do is like I want to use the same name as the signal name which I have used here. Just copy this signal name. Okay, just to paste here. Just paste here. Okay, now I have taken the voltage from this and peak current from this point. Okay, but I have plotted the graph here. Just I will delete it. Okay, now what I want to see is like I want to see the data in a graph format, right? I will choose this right click, and I will go inside this graphs, meters for controls, and add this overlay graph, and I will plot here. If you want, there is something called as canvas settings for this particular project. What it does is like it helps you to increase the size of the page, because now here you can see this, my size of the page is not enough for me to plot this particular graph. What I will do is like just to rest your mouse button here and just right click, there is something called as canvas settings, right? Just click here and change the option as A1 or A3. Here you can see this option has enlarged your page size. Now I can plot this data. Okay, I have plotted the peak current. Now I will try to plot this voltage. What I have to do is like I will go inside this graphs, meters for controls, and I will choose add overlay graph with signal, and I will keep it here. Okay, and what I to show the difference between what this value particularly does, this voltage input time constant, what it does, I will show. For this, what I will do is like I will keep this fault out of service. For this, what I have to give is like give a time which is higher than that. Okay, now what I want to see is like I want to see the what this time constant does in the system. Okay, whenever you have drawn something and you are going to run the simulation, before that please save the file. Before that, please save the file, and then you can perform the simulation. Please save the file and then go to home page, and click run. Can you see here at this point?
Yes.
Uh, this is what it does when you give a voltage time constant of 0.05. What it then generally does is like the time taken for my source to ramp up. Like that, we can say this is the time taken by my taken for my source to ramp up. This is like 0.5 seconds. Okay, if you want to choose, if you give here as 0, what it does is like it will directly start from the peak value itself. Can you see here?
Yeah.
There is no delay in ramping up and all. Okay, basically what the advisable solution is like, always give some time constant for this voltage. That would be much of a real time scenario case. Okay, always give a time constant as 0.05 or something, the value which you want. Okay, here I have chosen 0.05, so that what it will does is like it will ramp up in 0.05 seconds. That is the time taken to reach the particular the peak value. Okay, the peak value. Okay, like that you can perform the simulation for basic types. If you want to put a fault in your particular network, what we have to do is like we have to choose this fault from the main network. Okay, here you can see this more on breakers and faults, right? Just double click this and select this type of fault here. Choose this file, this fault. Okay, and paste here. Okay, if you paste here, it will appear here. Just copy it and paste it here, and here you can see the fault as appeared here. Here you want if you want to create the different types of fault, with this you can create a different type of fault, and what time your fault has to happen in your system. For that, what we can see is like here you can use this option to apply fault whatever the time. What this time says is like at what instant you are going to apply the fault, and what this duration of fault tells is like how much time your fault will last in the system. That is what this information tells you. If you choose for example, let me show this case. Like I will go inside this fault, and I will choose like 0.3 seconds is the instant where my fault is going to happen, and I'm just going to take this fault out of service within 100 milliseconds. Okay, for that I have done 0.1. Okay, my fault is going to happen at 0.3 seconds, and at after 0.3 plus 0.1, which is at 0.4 seconds, my fault is going to out of service, right? And I will just click OK. I will just save the simulation and I will run the simulation. Can you see here? No.
Yes,
In
I
the
can see.
current, yes, in the current, it has started in 0.3 seconds. It has started in 0.3 seconds, and at 0.4 second, which is 100 milliseconds after the fault has appeared, the fault has died out. If you are giving, and for that here you can see the voltage also. Here you can see the voltage also, right? After the fault has happened, my voltage has dropped down here, and after my fault has cleared at the 0.4 second, my voltage has again ramped up. Okay,
Yes,
this is yes, this is some uh, uh, basic modeling, how to create a fault, how to create a source, and what are the data we want to give to plot it in a graph or in a meter format. And other option which is available in this graph is like to display the data, right? Here can you see this? There is something a small
yes,
arrow in right side corner, right? If you click this, and if you click this extends, reset extends option, it will extend out. Now I have kept it in zoom condition. Okay, if I go and choose this reset extends, it will zoom out, right? And the other option which I am going to show is like this toggle markers. Just click this toggle markers. Before that there is no option is visible here, right? When you click this toggle markers, the option will appear here, right? Yes and O. Okay, this option is used to see the fault current which is appearing in the system. Okay, now what I will do is like I will double click on the x-axis. I will double click on the x-axis and I will go in the markers tab. Here you can see this markers tab, right? In this
yes,
markers tab, what I am going to see is like I am just going to give the value for X marker, and for O marker, what I am going to choose is uh, like 0.5. Okay, from 0.0 to 0.5, I am going to measure the value, right? For that, what I have done is like for the X marker, I have kept it as 0, and for the O marker, I have kept it as 0.5, and I will click OK here. Now here you can see this X marker is kept at 0 point, and the O marker has moved to 0.5 second. Okay, now here you can see this value has appeared here. What is the maximum value and what is the minimum value, right?
yes,
Okay, this is how you have to plot the current and voltage like this and all. Other data which are all available here, what other than that, what we can use is like if you are keeping zooming like this and you have kept this instant, and if you want to see the total y-axis, then you can use this option. Like there is something option to zoom y extents, right? If you click this, your topmost up to this up to your y point will be shown here. If you click zoom x extents, what it does is like it will show the complete waveform. Okay, this is some basics about how to plot current and how to see the voltages in the particular model. Okay, here you can see this voltage has appeared 202.511 is the voltage which has appeared here. If you want to plot the units, what we can do is like this you have to give manually only. Go inside this graph where we have given the name as voltage, and here you can see this there is an option called as unit. Just click here and keep it as kV, kilovolt, and your unit will appear in the y-axis. And if you want to give unit for the x-axis also, just double click this x-axis And here you can see this, there is something called as text title, and in that you can give seconds, and it will appear here in the x-axis. This is some basic about basic modeling about pscad, Himanshu. I hope you have learned something new today.
Yeah, Himanshu, like how comfortable you are with this? You have already know this, or probably new, or probably you need to practice. If you give your feedback, then probably we will be able to.
I done this. I done this. If you guys are done, I will share my screen. I done like couple of circuit like this, watching YouTube videos and
Yeah,
some
yeah.
examples.
Yes, please.
Share screen. Share screen. Can you
You
see
can
it?
stop it, Venkat. Yes, you can, sir. Yes, we are able to see your screen. Yes.
Yeah. So I created, for example, this is like the simplest thing. Electrical engineer will understand, like if it's a
Yes.
source and how does it work. So I done this, and then other than this, I tried to model like overhead line, but this was again using a YouTube video. So
Okay.
I tried to run, and it was running fine. To be honest, the data and everything is like without logic, because I don't do these studies, so I don't really understand how do you validate the study, or like what happens. But all like Venkat was showing other stuff, so like these other options I never explored. But yeah, like reset this and try to create fault logic meters. I done this a little bit. I was trying to learn this over the weekend, like capacitive compensation buttons and other stuff like that. So the way you teaching is you teaching as a tutor, but the way I done is just like random, whatever I wanted to learn, like I just watch a video and just done it. So this is what I've done, like three phase fault and fault logic and current plot. So yeah, I am well okay with this master library, how do you do this, and how you copy component, and how you do the basic plotting functions, adding, for example, control meters, stuff like that. So yeah, I've done this, and you can see it's a free addition. So this is the maximum I can go with this.
Okay.
Yeah.
Okay.
So this is all I have done basically.
Okay, then we will start up. I hope you have some knowledge, some basic knowledge about pscad. Then we will start up with the modeling of cables or transmission lines from tomorrow itself. Okay.
Venkat, quick suggestion. Like, okay, he's modeling it, but why to rather than jumping into the directly to the means simulation of modeling of cable or a transmission line, rather shall we give a single line diagram or something? Okay. Like means what say you might be aware, right? Means what say like 1.5 breaker scheme, and probably means what say main and transfer, double bus bar with the double breakers, correct? No. So like means what say let him expose it to the means what say equipments in the substations and different configurations that he can parallelly work on. Like he can try it on his own. Okay. And probably means what say we can take this equipments modeling also in parallel. So he will be able to visualize the whole substation perspective as well along this. Like means what say I guess means one equipment a day, or probably one equipment for 2 days, or if it's a small equipment means we can cover 2-3 equipments in a day. That could be the way we can go forward.
Okay, sir. Okay.
Himanshu, like how confident you are in reading the single line diagram of say 400 bar 220 kV substation? And
Yeah, I am okay with that. Yeah, I can definitely read it, but I need to install the pscad. You said the crack one in my personal laptop, and maybe try to model like the
okay,
the
now
thing
the
is that,
software which you have opened is in your official laptop. That's a trial
yeah,
version, is it?
it's a free edition. I don't know, I will speak to my colleague. They were thinking that they're going to buy a license, so I will ask them, but I don't think it will be any time before, maybe, don't know, May or June, July or something.
Okay,
But I will ask them just in case if they are progressing anything.
Yeah. But that's what, like you can personal laptop, you can install it and you can proceed, because I mean you can gain some confidence only when you're working in some large projects and handling it.
Yes. That's exactly what I wanted to do, because these basic things I try to create, what like watching videos and other stuff in my
Got it. That's a good
personal
work
time.
actually. You came with some basics actually.
Yeah, I told you I am a self-made man. No one ever taught or put the things on a plate for me. So I learn using my on time and on attitude. Yeah, and with this pscad and insulation coordination, I was saying to my colleague that I wanted to learn it from like last year. And this year only because of some bidding they are saying like, okay, you expect it to work. So how it will happen is like I create the model and I do the stuff, and then external expert who used to be a line manager of one of my senior director, he's very good at it. He got like 60 plus publications and other stuff like that, so he will like verify model and verify initial couple of reports, and then after that I am expected to teach to another colleague, and that's how it's going to be. So but from my point is more for my own interest and personal development.
Got it. Yeah.
So
That's
you
good.
want to give me some thing to do, or
Yes, means Venkat, like how do you see? Means shall we give means what say some single line diagram and ask him to model it in directly for this temporary over voltage? Like then he will get an idea like parallelly how to look at the project as well as how to look at the individual equipments. Is that okay, Venkat? Venkat?
Yes, sir. It is. I think he does knows about the modeling of sources. I hope. I hope
yeah,
you can model source.
because what you showing to me here is like a model. This shows I didn't model as a
As a regular
impedance or
source.
something. Yeah, but I just model like ideal source, and I try
Yes.
to use breaker logic. I try to put like line, just copy paste
Line.
from the existing project for logic, a variable load, and then try to control that load by this. That's all I have done in just using like pscad tutorial from XYZ
Okay.
person. I even seen the videos in Spanish language. To be honest, I am that
Okay.
desperate to learn. So
Okay.
then
Sir.
I try to create these random circuit, but they are without logic. It's not like a project or something. I saw like somebody is creating something. I just
Okay.
started doing it and created all these projects, and they are running perfectly well.
Okay. Okay. Fine. Okay.
So I was just trying to
Sir.
get some confidence, like
Yes.
if I for example run this. So I was just trying to gain confidence, like if I am modeling okay and it can run or it won't run. I don't know
Okay.
whether
Okay.
logically it's okay or not, but
It's not.
for
Okay.
sake
Okay.
of running, yeah, I was just trying to get confidence. Yeah.
Oh yes, it is nice work. Yes. Yes.
Yeah,
So,
so I
sir,
I I try to
sir,
model.
then we can start up with modeling of sources itself, sir. So,
Okay, fine.
yes.
Okay, Venkat.
Then
That's
how we can
that's
model, how we used to model the real-time source, and how we try to match the fault current levels, and then from there only we used to start the modeling
Yeah,
of.
but one thing you need to understand, like means what say, he's not moving from power system studies to insulation coordination. Power system studies, like when you go source modeling, you need to like what's the short circuit level, what's the X by R ratio, which we are getting a short circuit report itself. You have to probably spend a little time.
Yes, sir. Yes,
Yeah,
sir. That is
Yeah,
what I'm telling. We will
yeah.
project that, and how we get the data from the customers, like that we will tell him.
Correct.
That-
Means
yes.
what to say, like means what to say. My view is mixing up little bit of ETAP, Venkat. Like means what to say. Anyway, you need a short circuit, correct? No.
Yes, sir. Right,
So
right, sir.
means
Right.
my view is like based on his experience and what's his feedback. My suggestion is like I mean, what say someone takes maybe 1 hour or 1.5 hours for a short circuit study. Okay.
Okay.
Anyway,
Okay.
that's needed for us, right? I mean, so the customer will give like three-phase fault current, maximum, minimum, single line to ground fault current, maximum, minimum X by R ratio at the grid, and how you are putting it in the grid is, I mean, source is what we are going to explain. But
Yes,
means
sir.
what say how to get that value, he will know only when like he performs short circuit study, correct? No. So
Right, right.
like I mean, so say jumping directly to pscad, okay, I mean he's good at it, he's able to self-learn, that's fine. But if he comes with that knowledge also, that will be in a long run that will help him actually. So
Help him.
that's what
Yes,
my
yes.
view. Himanshu,
anything,
like
anything I need to do in order to learn these four studies, like switching over voltages and the lightning over voltages and integration of this, like a PV or wind farm, and VFTO. I am more than happy to do anything. And I told you, like, I watched video in Spanish language and French language and some language where I don't understand, but I know what guy is doing and what he's trying to do. So I'm okay to learn. It's
all
good
right,
good for me.
all right. Even to say like this PV and wind also, like let someone start in ETAP. Okay.
Okay.
Then later we
Okay.
can go to pscad. That's what I feel. No problem. Himanshu, like means what's the base? I got something like from the discussion, like where you stand and what you need. Okay. So I will come up with a plan, but we will not think it probably for a long run. Let's plan maybe 2 days at a time or 3 days at a time. That means a week at a time. Okay. We will do the work. Then we will take it up the next week. Not really means what say. If you look at means what say the total plan, then probably means it depends on the resource availability. It may get collapse. Let's look at 1 week at a time, and then we will means what say progress. At the end of the day, probably means we will ensure like you are getting everything.
So are we going to do anything tomorrow then?
Yes, that's what I felt like. Means what say we will share a single line diagram in a WhatsApp group.
Yes.
Okay. You read it and probably try to model it whatever you can, whatever possible which you can. Okay.
Yes.
And then come back like we can correct it. So I'm taking two things in parallel. One is like you need to understand the project steps, but of course means you need to look at the individual equipments, how to model that also. So we will take this both together so that at the end of the course you will learn both.
Yes. That would be brilliant. Yeah, that would be nice.
Yeah, right. Fine. The tomorrow session is scheduled at means India time 1:30. Correct, no?
Yeah, that's right. Yeah, mine is
Yeah.
8 o'clock. Yeah.
Yes. Fine.
After 26th of this month, there will be one reduced hour. So if you wanted to keep the same, you can keep same, or if you wanted to change, you can change. So at the moment, there is Indian time is 5 hours 30 minutes ahead of the
Okay.
UK time. So
Yeah.
after 26th March, it will be 4 hour and 30.
Got it.
Yeah.
Got it. That's fine. Like I mean, so we will take a call. Means we also don't want to rush the course in means 4 hours, 10 hours in a week. That days like we planned. Like I mean, so we do 2 hours a course. We will give assignments quite a lot. We expect you to work. Then we will come back review and again some assignments. So like means what even I personally feel like. Means we generally recommend this like means if you're attending a 2 hours course when it goes to the simulation modeling what we are teaching then you need to practice that for 20 hours so that's the equation we generally say.
No,
So I mean,
it's good. I can do that, but what my point is because if I do this 2 hours each Friday, right, 2 to 2.5 hour or maximum 2 hour, let's say, and then if I do weekends like 3 to 4 hour, like Saturday, Sunday, 3 to 4 hour, then I get more time in between these days, Monday to Thursday, to practice
yeah,
it. The reason I wanted to do it because I'm expected to do a project, right? So I can do that with this all training, and even if let's say I'm not taking training, I can do with the help of that external guy. But
okay,
what I'm trying to gain is I'm trying to gain more confidence and more experience on the software, and I'm just trying to seek my further career progression. So
that's perfectly all right. Yeah, got it.
so that's what my point is. So my aim is to of course learn line coordination and then switching and studies with respect to like AI substation or like wind farm integration or for example the project I am going to attack. So if I get anything on that information, so I will maybe try to show you a single line diagram and try to explain like this is how I think I can do it at the end of the course maybe. So will be helpful for me.
Sure.
No worries. Then I will let you guys work on, and I will wait for the single line diagram, and then I will see you tomorrow again.
Yeah. Thank you so much.
Thanks for your time.
Thank you.
It was
Thank you.
just
Thank you.
good session, good presentation.
Thank
And
you.
I didn't want to disturb you guys, in the presentation banquet because I know you're trying to teach from your point of view.